So, first order of business. What do you have tomorrow?
Also, I turned in that lab and it still says zero. So I was like, not putting it in the right place or something.
Where'd you put it?
I thought I gave it to you in that basket.
That's what.
It's been in the right spot.
I have that after a ball today in Foursquare.
Did you screw it?
I'll just pass these over now. Aaron. Okay, so first order of business. Let's talk about your lab tomorrow. So about half classes have voted and chose your favorite soft drinks. What is this?
I never did vote.
I didn't like it.
What was on the options?
So on this, I will be purchasing the drinks later on. Tomorrow, I'm going to go over everything that you will be doing in the lab tomorrow because the God's honest truth is there is no reason you should not be able to do it because you've done it all before. You're just doing this on a larger scale. So, on this lab handout is not correct. Okay? This lab handout says graduated cylinder. Everywhere it says you're going to put 10 milliliters in the graduated cylinder is wrong. What is the most accurate and precise glassware we have?
Isn't it like the pipette?
The pipette. So we care about accuracy and precision in this class. So what do you think we're going to use?
The pipette.
The 10 milliliter pipette. So,
See, I have learned something.
you have. This is literally what you're going to do. This is what you will do. Just like we did with the accuracy and precision lab. You have a beaker on a scale. You'll tear it. So it reads 0 because we don't want the mass of the beaker. We want the mass of the substance in there. And you will find the mass
Kylie Powers, come to the office.
of 10 milliliters of the solution. Now, in this case, there's 5 solutions back there that I've made for you that you must have. The first one sitting right here at the first lab station in the Erlenmeyer class is 1% sugar concentration. Back there in the middle lab station, going left to right, is 5%, 10%, 15%, and 20%. I made those solutions. And this is what you will be doing. With those solutions and with the soft drinks tomorrow, you will be finding the density of them. And density is equal to mass divided by volume. Where's the mass coming from? Where?
The liquid.
The drink. So that's what liquid mass off of. What are you going to find it with?
Pipette.
Off the scale. The value you get from the scale. This is where I made your life a lot simpler. You're welcome. Volume. What's volume going to be?
How much of liquid?
10 milliliters. Why is it 10 milliliters? Because what you're saying is true. Why is it 10 though?
Because that's what we're trying to use.
Every trial, 10 milliliters. Doesn't change. Makes life really great for you. I'll go on and tell you one of the solutions back there. I remember right, I got 10.5 585 as grams. So there's the mass. Life's really simpler for you now. Because if I want to find density, I gotta divide by 10 to give me so now I found the density of that. Now with this, we're going to use this data. Tomorrow is all about getting the data. So later on, we'll go in here, we're going to create a line, and with that line, we can work backwards and find out the sugar concentration within our soft drinks. And then, based off the labels on the soft drinks, we will determine whether or not we're accurate and precise or not. Okay? Any questions on the lab tomorrow? If you have a question, now's the time to ask me, because I'm going to get so mad when people come in here tomorrow and they're like, how do we do this? I don't know what I'm doing. We're recording it right now, so you should watch this. If you're not understanding, those people that come in tomorrow say, I wasn't here. Doesn't matter. Get on my class. Anybody else come in besides Leah, Haley, and Kendra? So no questions. That's literally the lab tomorrow. I'm gonna create a table for you guys to make your life a lot simpler, so you can just record the data as you're going. Please, if you have questions, ask me. This is your opportunity right now. Go once, twice. So y'all are all good to go in the lab now. I'm good to go. When y'all come in tomorrow, we'll go straight to lab. Alright, so let's work some practice problems. Yesterday we did a really hard problem. Today we do not so hard problem. So, what is the wavelength photon with a frequency of, let's just make something out of nowhere. This problem's not that bad, and I'm going to create one next to it. How much energy photon electromagnetic radiation if it has a frequency of 1 problems, I'll give you a second right now. Leave some space between them. I'll openly look at you and tell you that your favorite problem out of these two will be the one on the right. It is the more simplistic and easier one. So in this, let's work this problem. You need a hand calculator. So in this, what is the wavelength of a photon with a frequency of 6.78 times 10 to the 14? This is the key. Look where I'm starting you. Starting you with the frequency. It's a dead giveaway for you. You're going to either be starting with frequency, ask to find frequency, or you're going to have to go through frequency. If you are given frequency, or asked to find frequency, you're going to use one equation, and that's it. If you're not asked for frequency or given frequency, you will have to use both equations. So in this, I'm starting with frequency, so I know it's going to be a one-step equation. From there, look at what you're being asked for will tell you which equation to use. What is the wavelength? So in this, the wavelength tells me which equation to use. It's either going to be using energy or you're going to be using speed of light. So in this case, we're looking at wavelength, and that is in the speed of light equals to wavelength times frequency. Now I'm trying to find wavelength, so I got to get wavelength by itself. They're being multiplied together here. So if I divide both sides by frequency, because we're multiplying, frequencies cancel on the right to leave me with wavelength equals the speed of light divided by frequency. And then from here you can just plug it in. 2.98 times 10 to the 8 meters per second divided by frequency, which I gave you to be 6.78 times 10 to the 14 hertz. Hertz and second cancel. Put this in the calculator. And you should get that answer. Now, I highly recommend at this time, especially with most of the class gone, I would take this time, punch this in the calculator, make sure you're getting it. I'm not in that big of a rush in this class because this right here is literally, y'all are ahead. Alright, I'll just give you one. Y'all are ahead of second period right now. Well. If you cannot get this, tell me.
to like move them around or yeah.
That's why they were your favorite.
Two times this.
Divide. You guys didn't know what a fraction is also division. Is there any questions here on this problem? Over there on the view board I have how I punched it in my calculator. Alright, let's look at this one. How much energy does a photon of electromagnetic radiation have if it has a frequency of 3.62 times 10 to the 14 seconds to the negative 1? Now I did this on purpose. Here's your starting point. That's what you've been given. It's frequency. Those units right there is hertz. But I gave it to you this way so you don't get so caught up on having to see hertz. The inverse seconds is hertz. Remember, 1 over seconds equals seconds to the negative 1 equals hertz. Now in this, what equation are we going to use? Because we've been given frequency, which means it's one equation. Which one? Energy, because you're asked to find energy. So energy equals Planck's constant times frequency. And this is why it's going to be your most favorite. You don't have to switch it around. You literally just plug a number in.
But do you multiply them or do you divide?
What's being done right here?
You multiply them. I thought you were and divide.
I thought you was talking over here.
Oh, okay. Well, I didn't know.
So, 6 point stitch times 10 to the negative 34th joules seconds times frequency, which in this case is 3.62 times 10 to the 14th inverse seconds. In this case, seconds and inverse seconds cancel.
Tanner Workman, Wesley Browning, come to the office, please. Tanner Workman, Wesley Browning.
Six times joules. So in this problem, I get 2.3986 times 10 to the negative 19 joules. How y'all feeling?
I like it. It's a lot better than mine.
Questions? Can I erase the first one? If you're still working on the second problem, keep working the second problem. If you're not, work this one. What is the wavelength of a photon with a frequency of 7.64 times 10 to the 14th hertz? Yeah, I want you to give us a shot. Okay? Work this yourself. Believe you can do this.
Can you tell me what I did wrong?
I absolutely can. You divide it. You should multiply. This is the thing, guys. Don't get in the habit of just doing something because you just did it. Understand what you're doing, what you're being asked for. See, Jack there. This is why your calculator is reading it as negative 34 divided by 3.62 e to the 14 as that exponent. Or divide. Yeah, that's my bad. You're dividing and you should multiply.
How do you know when to?
See how they're side by side? That's multiplication.
Okay.
When one's on top of the other, it's division.
Brady St. Clair, come to the office, please. Brady St. Clair.
Once you get an answer to this first part, answer this part for it. What type of electromagnetic radiation is this photon? And if it's visible light, state your color.
Doesn't no one do all that other stuff we did yesterday?
Everything we did yesterday, what did we do it for?
That, right?
We did, but we worked to find what? Out of the three relations, frequency, energy, or wavelength. We worked to find the wavelength. You just solved for the wavelength. So now take the wavelength, do whatever you feel is necessary, and look at if it's, well, identify what it is. Answer-wise, that's what you should get for the answer on top.
I did that much.
for here yet? This one's pulling on you. If you can't answer the pink yet, I ain't worried about that. I want you to be able to answer this, but I want to get you where you can answer things. How many of you got UV rays? Okay, keep working. As to why I could get 390.05 nanometers, I just did the conversion. You should be able to do the conversion by now and see this 390.05 nanometers off of the electromagnetic spectrum over there. If you look, where does the visible light spectrum stop? 400 nanometers. We're slightly to the left of it. If you go slightly to the left of visible light, what do you find?
Ultraviolet rays.
Ultraviolet rays. That's why that's UV rays.
Yeah, I think the -7 was written on. I don't know how to do it.
How do you convert
You
it?
can, but the thing of it is look at the -7 while you're sad.
Yeah.
Can you do that with every phone?
Not always. Because look at the areas where it splits.
That's what I do.
Okay, wait. How do you solve that again? Like, I get, like, changing it to nanometers, but...
Okay, so then when I get it to nanometers, I look and see where this number's falling, this wavelength falls on the electromagnetic spectrum. How I did it is I looked and I said, visible light ends at 400 nanometers. Go to the left of it, which I am barely left of 400 nanometers. Where do I fall? Ultraviolet. They looked at it and said 10 to the -7. That's not always going to work that way. Worked out this time, but if this was 4.6 times 10 to the -7, look where -7's at. Behind -7, you're still falling. Huh? It can be in, yeah, that would work. But whenever you're looking at this, look between 10 to the -7 and 10 to the -6. As soon as you pass 10 to the -6, you're at 10 to the -7. In that area, in that range there, all that's falling in there. So ultraviolet and visible light's falling within that. That's why I'm saying don't look at that as a guarantee. Alright? Any questions on this? For all of my people that are,
Yeah, I don't know how you got that.
which one?
The pink part. I'm still so confused.
Okay. Can you get this?
Yes.
Can you convert it to this?
Yes.
Okay, once you do that, look at the electromagnetic spectrum. Whenever you look at it, you're looking at the wavelength of it. So, look in here. Here's the problem. 10 to the -7's here to there. So all of that is falling within it. So whenever I look at it, this is what I do, is I look here at my visible light spectrum
Ashley
ends.
Day, Madison Atwell, Hayden Kevin, come to the office,
at
please.
400 nanometers.
Ashley Day, Madison Madison
So I'm
Atwell, Hayden Kevin.
just shy, but I'm sitting right in here somewhere, but I'm not visible light. What comes after visible light?
So you change it to
So-
nanometers on every one.
I'm looking at ultraviolet.
I'm trying to find the color, yeah.
That makes sense.
N is -9.
So you do.
So I know how to do the conversion, like we did, but how do you get that number?
Okay, this is what you gotta do, is you'll get speed of light equals wavelength times frequency. You're trying to find a wavelength, so divide both sides by frequency, which gives you wavelength equals the speed of light divided by frequency. Did you get there?
Yeah.
And then did you do,
I'm talking about meters to nanometers.
oh,
Write it out.
3.9005 times 10 -7 meters equals how many nanometers? Apply the rule that we've always done. 3.9005 times 10 to something another. Prefix conversion first. Meter. There's no prefix to base units, the number's 0. Subtract the difference for nano. So minus a negative, same as adding the positive. So 9, and then add what you originally started with. So gives me a positive 2.
Oh, okay, I see. Try to
And-
get 7. I'm just supposed to add 7.
Yep.
Okay, but after that, when you get your exponent, how do you get rid of the exponent and get that
This is
number?
what I do, is I look and I say, this is 10 squared. What's 10 squared equal to?
100.
So 100 times 3.9005.
Oh, okay.
So whatever the number is, you'll end up timesing it by your 10 to whatever power.
You don't have to. I just do it because of how it's represented on visible light spec.
I know, but it seems like that'd just make it easier though.
That's why I do that.
So could you just like move the decimal places? Would that work on?
I hate it when people say that. You're not moving the decimal 1 or 2 places. You're multiplying by 100.
So you have to do that on every one of them.
You don't have to. I recommend it. Now realize, in this question here, do you have to convert this into nanometers? Just answering this question here in the black. No, I asked you for a wavelength. This still is wavelength. You're 100% right here. Just when this pink part gets added to it, that's when you want to convert it to make your life a lot easier when looking at the spectrum. Okay? Everybody feeling good?
Yeah.
So you never said what color.
It's because it's UV rays. It's not visible light.
So you do 10 squared.
The only way you'll have a color if it's
Is
in
if
the
it's
visible,
before that
if it falls into that,
and so in this one.
in that little spot. That's it.
For the test, will we be getting one of those?
Yes, you get the one that I gave you, this black and white on the back, and then I'll put that one up there in case I ask you, and something ends up actually having a color. And if you're colorblind, you need to tell me now. Are you serious? Because I actually had a girl that was colorblind. Yeah, everybody asks about that, how Colton Morgan made it, and somebody was like, Colton, you ever had this? All right, I'm going to change this one up a little bit here for you. How much energy does a photon of electromagnetic radiation have if it has a wavelength of There we go. See if y'all can solve that one. It'll be the last one for you.
Is this the two-step one?
Yes, it's a two-step one. How do you know it's two steps?
Because it's not frequency or we're not.
Given frequency. Good catch. So that means you're going to have to use both equations.
That's right.
Did we do that yesterday?
You did. The key to using both equations is whatever value I start you with, that's the first equation you use. Figured that would help you. Listen. What is it? You're finding it. Using
I'm
energy.
not too sure how to start this one.
Alright, so the first thing you're going to do is where do I start you at? Starts you with wavelength, so you have to use the equation that uses wavelength. Speed of light equals wavelength times frequency. How are the two equations joined? What do they share in common? Frequency. So we have to solve for frequency and then we can find energy. So divide both sides by wavelength. So frequency equals speed of light divided by wavelength. Now this is the key. What's the speed of light in? What's the units? Meters per second. Red flag. Can you use nanometers? No, you have to convert. So 360 nanometers equals how many meters? 360 times 10. And that's got nano first. -9 minus meters, which is 0, equals -9. I didn't start with nothing, so I don't have to add anything to it. I get -9. So now you can do this problem. So divide it by 360 times 10 to the -9 meters. Meters cancel. Once you get that, you get 8.28 times 10 to the 14th hertz. Once you've done that, you then plug it in the energy. Energy equals Planck's constant times frequency. That number plugs in for frequency. So it's 6.626 times 10 to the -34 times 8.2778 times 10 to the 14th. And you get an answer 5.4849 times 10 -19 joules is what you should get.
How long we got?